Hello students, welcome back to the channel. So today we'll be taking two important definitions of valency. The first definition is the number of hydrogen atoms which can combine with or displace one atom of the element or radical forming a compound. Now in this definition we'll be taking the help of three examples, that is HCl, water and ammonia. Now in all the three compounds you can see that hydrogen is the element that is present. Now how to understand the valency of chlorine in HCl? Now if you see that the number of hydrogen atoms present in HCl is one atom of hydrogen combining with one atom of chlorine. Okay, so one atom of hydrogen is combining with one atom of chlorine to form a compound of HCl. So the valency of chlorine with respect to the number of hydrogen atoms will be 1. Why valency of chlorine is 1? Because the number of hydrogen atoms combining in the compound is 1. Because one hydrogen atom is there, therefore the valency of chlorine with respect to the number of hydrogen atoms will also be 1. In the second example, that is water, how many hydrogen atoms are there? Now two hydrogen atoms are combining with one atom of oxygen to form water. Okay, so because two hydrogen atoms are combining, the valency of oxygen with respect to the number of hydrogen atoms will be 2. So here every time we are determining the valency of the element with respect to the number of hydrogen atoms. And in the last example, that is ammonia, now it's very clear, you can identify what will be the valency of nitrogen over here. The valency of nitrogen here will be 3. Why? Because the number of hydrogen atoms that are combining in this compound is 3. Because 3 hydrogen atoms are combining with one atom of nitrogen, the valency of nitrogen with respect to the number of hydrogen atoms will be 3. So that is what the definition of valency with respect to the number of hydrogen atoms states. So remember these three examples. HCl, valency of chlorine is 1 because how many hydrogen atoms are there? 1. In water, what will be the valency of oxygen? 2 because how many hydrogen atoms are present? 2 hydrogen atoms are there. So we are comparing, or we can say, because hydrogen is the first element, we have taken it as a standard for finding out the valency of the other element. And likewise in ammonia, because 3 hydrogen atoms are combining with one atom of nitrogen, so with respect to the number of hydrogen atoms, the valency of nitrogen is 3 in the compound of ammonia. Moving on to the next definition, it states that valency is also the number of electrons donated or accepted by an atom so as to achieve stable electronic configuration of the nearest noble gas. So every time the elements, whether it is metal, non-metal, they'll be either giving or taking in electrons. Why? So as to acquire a stable octet configuration. It means each and every element wants to acquire stability, and which it will be equivalent to which nearest noble gases? We have noble gases like helium, neon and argon. Helium acquires a stable duplet configuration, neon acquires a stable octet configuration, and argon, the configuration is, electronic configuration is 288. So we'll be seeing that how the elements, metals, they'll be giving away electrons in order to have how many electrons in their valence shell? 8 electrons they will have in their valence shell. So valency is, this is the second definition which you need to remember in terms of either losing or gaining electrons in order to acquire stability to the nearest noble gas. Okay, so now firstly we understand for metals. Now metals, you will remember, they will always give away electrons or they will always donate electrons. So you can say that they are very generous, they are always giving, they are very good friends. Like that you can remember that metals are good friends, they always give. Okay, So the electrons will always be donated by metals. And remember that metals have got 1, 2, 3 electrons in their valence shell. Now what is a valence shell? It is the outermost shell in an atom. So the outermost shell will always be either losing electrons or gaining electrons in order to acquire a stable octet configuration. Okay, and whatever the number of electrons the metals will lose, whether it is 1, 2 or 3, that will correspond to its valency also. So let's first take the example of sodium. Sodium's electronic configuration is 281. Because it has got one extra electron in its valence shell, it will give away that one electron to form a positively charged cation, and its configuration will change to 2,8, which is to the nearest noble gas neon. Neon has the electronic configuration of 2,8, and because it is giving one electron, its valency will be +1. So what will be the valency of sodium? +1, because it is giving away that one extra electron. Next, if we take the example of magnesium, its configuration is 282 and it has got 2 extra electrons in its valence shell. So it will lose those 2 electrons to form, magnesium will form positively charged. 2 plus will be the charge on magnesium ion, and its configuration will be 2,8, which is also to the nearest noble gas 2,8. Okay, and because it has given away 2 electrons, the valency of magnesium over here will be +2. So here we are determining the valency of the elements with respect to the number of valence electrons which they are losing. And lastly, we will take the example of aluminium. Now aluminium, its configuration is 283. It will give away 3 electrons, and because it is giving away 3 electrons, its valency will be 3 plus, and its configuration will again be closest to the nearest noble gas, that is neon. Neon has 2,8 electrons and its valency will be +3. Okay, so the fundamental concept which you will remember for metals, that metals, they always give away electrons, and metals have always got 1, 2, 3 electrons in their valence shell. What is the valence shell? The outermost shell, which participates generally in the bond formation also, which we'll be seeing in the next video. So here you have to remember the core concept. Metals, they have 1, 2, 3 electrons in the valence shell, and they always lose or give away these electrons. Now moving to the next elements, that is non-metals. Now non-metals will always gain, or they will always keep accepting. Okay, they will always gain or accept electrons. So we can say that non-metals are very selfish. They always want to take and take. Metals are generous. They always give. Non-metals, they always accept. And non-metals have got 5, 6 or 7 electrons in their valence shell, and here also they will gain electrons in order to complete their octet. So if we take the example of chlorine, chlorine configuration is 287. Now in order to achieve stability, it has a deficiency of 1 electron, so it will gain 1 electron, and because it is gaining 1 extra electron, it will acquire a -1 charge, and its configuration will change to 288. That is, chloride ion will be formed, which is closest to the nearest noble gas configuration. Argon has a electronic configuration of 288, and because it has gained 1 extra electron, its valency will be -1. Next, if we take the example of oxygen, oxygen configuration is 2,6. Now here if you see how many electrons it requires to complete its octet, it requires 2 electrons in order to complete its octet. So it will gain 2 electrons, its valency will be 2-, that is oxide ion. Its configuration will change to 2,8, which is closest to the nearest noble gas neon. Neon configuration is 2,8. And because it has got 2 electrons, it has gained 2 extra electrons, the valency of oxygen will be minus 2. So that is what you need to understand in this part. You need to learn both the definition of valency, keep the examples in your mind, and that will help you to answer the questions. Definitions, every time I keep telling you children, please learn it as it is given in your textbook. Don't create your own definitions. Learn the definitions as it is given in the textbook so that you can score full marks if a particular definition is asked in the exam. And please go through the examples so that you're clear on the concept of valency, because it is one of the most important concepts in this chapter, and definitely you'll get questions based on valency. So hope you have understood, you have followed. So in the next class we'll be talking about the formation of compounds from atoms. Thank you, students.